Hi, welcome to online tutorial series, and this is live tutorial series from JCBRO Labs. We also provide online training, help in technical assignments. We also do freelance projects based on data science, Python, machine learning, etc. So if you have any such requirement, then you can contact us through our website, which is www.jcbrolabs.org, or you can also mail us at uh, info@jcbrolabs.org. Okay, so let's start for today. So there's a special for today's live session. In today's live session, we will are going to ask some questions, and if you are the first one to give the correct answer, then we will provide some cash prize to you. Due to some transaction limitation, this cash prize scheme is limited to Indian students only, because we will be using this UPI transaction mode for this transaction. Okay. Otherwise, for foreign students as well, we have some other other prizes or other methods, and we are working on it. So please remain with us in order to in order to get the information about it. Okay, so let's wait. If you have joined, some students have joined us, so let's see. Okay, let's continue. Okay, so in today's session, we are going to talk about the addressing modes. Generally, addressing modes are used how the data is transferred between memory and different registers. And then we will talk about the ports and its assembly language programming using KEIL ID. Okay, so let's come up with our first question. Okay, so our first question is like what in our last tutorial videos we talked about the uh, RAM structure, right? And we talked about the stack as well. So our question is related to stack only. So what is the question is, what is the content of stack pointer, that means the SP register, as soon as 8051 gets powered up? Okay, so as soon as we apply some power to 8051 microcontroller, so what is the default register value, default SP register value? Okay, so you can think about it and then answer it. In the meantime, we will continue with our today's theory. So today we are going to talk about, as I mentioned, we are going to talk about addressing modes. So the first one answer means like whoever name comes first in live chat. Okay, so addressing modes are like so there are total 5 addressing modes are available in 8051 microcontroller, and the first addressing mode is the immediate addressing mode. Okay, so I will write it short: immediate addressing mode. So in immediate addressing mode, the data is directly transferred to any register. Okay, so let's see if anyone come up with the answer yet. No, not anyone. Okay, now in the, so the command could be like move a comma, let's say we type hash 15h. So here h represents the hexadecimal value. So this data, this hash represents that this 15 is the data. So right now this data is directly transferred to the memory, to the accumulator. Similarly, we can write like move r0 comma hash 10h. So in this case, this 10 is directly transferred to the register 0. So this could be any register of any register bank. As you know, there are total 4 register banks are available. So this is the immediate addressing mode. Data is directly transferred to the register. Now, in order to specify whether that particular thing is data, we use this hash sign. So this hash sign represents this number is the data, not the memory location. Okay. So the we'll jump uh, we will jump to the next question. Okay, we got our answer for first question. That was like 01H. Okay, so Bhavna Sharma, we will provide her 10 rupees INR, and we will directly transfer to after submitting a link. So she will be, so she will get 10 rupees INR from JCBRO after submitting a form with us. Okay, so that form will be submitted to the after of this live session. We will share a link. Uh, okay, and this person can send us a mail, and then we'll send a link to her. It will she will fill a form, and then we will provide the transaction. Okay. Okay. Hello, Divya. Okay, coming to our further to our theory part, another addressing mode which is generally used is the register addressing mode. Okay, so in register addressing modes, the data is transferred between the registers. Now, this register could be anything. Okay, it could be any one register. For example, if I type move a comma r0, so r0 content is moved to a. Similarly, if I type move r1 comma a, so the accumulator content will move to r1. So this kind of addressing mode is known as the register addressing mode. Now coming to the third addressing mode. Third addressing mode is the direct addressing mode. So in direct addressing mode, data which is available at some memory location or the RAM location, which is available at the RAM location, that is directly transferred to the any register. Okay, so we'll just talk about it. Okay, and so the direct addressing mode is looks like, let's say if I type move uh, register 1 comma 50h, right? So what is happening here, let's say it is a 50h location within the memory, and it is written here 11. H is representing the hexadecimal, so that 11 will be transferred to the R1. So let's say this is our register 1 of any register bank, depending on the PSW works. So this data will copied here as well. Okay, so let's say if we type move a move, we can also pass the value to the location. So let's say move 40h comma r2. So what will happen here, the content of the r2 will be copied into 40h. So let's say here is our r2 register and 5h is written there, and here is our memory location, RAM. When I talking about this memory, so I means to say the RAM location, and its address is 40h. So this 5h will copied here, so the content in this 40h will be 5h now. Okay, so this is how this direct addressing mode works. Now we will come to our second question, so you should listen it carefully. So our the second question is, and that is very easy, what is the size of RAM which is available in 8051 microcontroller? Okay, so what is the size of RAM which is available to 8051 microcontroller? So answer carefully. We have already talked about in our last videos. Okay, so let's see who comes up with the answer. In the meantime, we will move forward. So we have talked about this three addressing mode with the with the examples. Another one is the, and very interesting one is the register indirect addressing mode. Okay, so let's increase it. Okay, so let's talk about the register addressing mode. Register indirect addressing mode. Okay, here we come. So the next is the register indirect addressing mode. So in register indirect addressing mode, the registers acts as a pointer. That means they points to some memory location, and whatever the content in the register is, that particular content acts as the pointer to the memory RAM memory location, because register is also 8-bit and memory location is also because RAM goes up to, I hope you know the answer. RAM goes up to, let's see if anyone has given the answer. No, so I will hold on here. Okay, Prince Sharma has given the right answer. So yes, memory location goes from 0 to 120 kilobyte of memory location. Okay, Bhavana Sharma, you are late. Prince Sharma has given the first, so he's right. Okay, so Prince will get or point. So as you see, the price varies depending on the question, right? So Prince will get 20 INR. Prince will send us an email and then we'll share the link of the form to him. After filling the form, we will transfer the remaining amount. Okay, coming back to programming. Yeah, I was talking about the address register and direct addressing mode. So in this, the content of the register acts as a pointer to the memory. So for example, if I say move a comma at r0 r2, right? So let's say here we have our register r2 and it is written here, let's say 40h, right? And here is the memory whose location is 40 and it is written here 12, and here is the accumulator content. Okay, so in this addressing mode, it is like transfer the value at location pointed by R2. So R2 points this location. So this content, the content which is available at this location, which will be copied into accumulator. So the value in the accumulator will be 12. Okay. So this is how this works. If let's say taken another example as well, so that you can understand it correctly. For example, if I type move at the rate r1 comma at the rate r3. Okay, so now there are two, right? Okay, okay, here we have some issues here. Here r2 cannot be used, only the r1 can only be used for this purpose, right? So this r0 and r1 can only be used for this transfer purpose. So sorry for wrong command, so I should make it r1. Okay, now so this should be noted, only r0 and r1 can be used for this register indirect addressing mode. Okay, now if we type move at the address of r0 comma, let's say r5. Okay, so in that case what is happening, let's say we have register r5 and here the content is 10h. Here we have register R0, and the content of R0 is 50h, and here is our memory. So, and memory location is 50h. So what is happening? This content 10h will be transferred to the location pointed by this R0. So R0 points to this 50h, so this 10h will transfer here. So it will return here 10h. So the content of this memory location 50h will be 10h now. Okay, so it should be remember that this in the register addressing mode is only available, register indirect addressing mode is only available, can be done through this R0 and R1 only. Okay, now there is another addressing mode that is known as the indexed addressing mode. So that is the fourth addressing mode, right? Indexed addressing mode. Okay, now before indirect addressing mode, it is a little bit confusing. So let's talk about it. We have two type of memories: code memory and the data memory. So code memory is that memory in which code is written. So the hexadecimal codes which we burn, that particular code is written. So that memory is known as the code memory. And in microcontroller, that is known as the ROM, read only memory, because it can only be flashed during the program. Once program is done, the content of this cannot be changed generally, right? And then within this RAM, so we have total 64 KB RAM available to us, right? So 60 kilobytes, so capital B stands for the bytes. 64 kilobytes is available to us. So within the code memory, sometimes we can store some data in the form of like arrays or something. So that particular data can also be stored within this memory only. So if that is the case, in that case, this indexed addressing mode is used, and there is a specific command for this, that is move c a comma at the rate a plus dptr. So remember this dptr register. So I think this could be a new to you. This dptr is known as the data pointer. It points to some data which is stored somewhere in the memory. So generally sometimes it is stored directly into the code, that some data is stored directly into the code. Sometimes data can be stored into the data memory, that is separate. Okay, so right now we are talking the case when data is stored within the code memory only. So that is a part of a code as well, like lookup tables and like that only. So this dptr is a 16-bit register. Okay, so that is why it can goes from 0 to 64 kb. So total 64 kb of data can be accessed, or 64,6535 memory locations can be accessed through it. So its uh, index is like this. So here is, if let's say we have dptr, value of dptr is 400 and value of content a is 10. So at the address of, it will become 10 plus 400, so 410. And at that particular memory location, whatever the content is, let's say 50h is written there, that location, that data will be transferred into the accumulator. Okay, so I hope you are getting it. So it will add the address at this, at a plus dptr, and at that memory location whatever the data is, that will be transferred to the accumulator in this case. So specifically for this kind of addressing mode, only this particular command, move c command, is used, right? Okay, let's see if anyone has any doubt. So if you have any doubt at any point of time, you can simply ask directly to it, right? Directly to us. Now the last instruction, or the last addressing mode, is the indexed the last addressing mode is indexed addressing mode. I think we have missed something. Let's see. Okay, we talked about index, register, indirect, direct. Oh, sorry, this register indirect was the fourth one, and this indexed addressing mode is the fifth one. Okay, and within that there is one instruction, this move C, and the another one instruction is move X. So actually sometimes got confused during the live because we have to manage the separate things. Okay, so there's another instruction that is the move X command, right? So it is different from the move C command, and then this particular command is used to access the data from the external memory location, right? So as I said, there could be two memories. So if separate data memory can also be connected to the 8051 microcontroller. One is the code memory, one is the data memory. So 64 KB of code memory can also be connected to it, and 64 KB of data memory can also be connected to the 8051. So if we want to access the data from this data memory, which is other than this C code, then we have used this move X command, where X represents the external, right? And this the C in this move C command stands for the code memory. So these are the total five addressing modes: indexed addressing mode, register indirect addressing mode, direct addressing mode, register addressing mode, and the immediate addressing mode. So these are total five addressing modes which are generally used in 8051. Okay, so with that we will move forward to the second thing that was the part of our today, that was the port programming. Okay, so in our last session we talked about what are the ports. So let's say you can think of the ports as the hands hands to human body. So ports are the locations from where data input output take place, right? So P1, P2, and P3. So there are total four ports are available to 8051 microcontroller: port 0, port 1, port 2, and port 3. So these are the locations from where data in and out, right, in and out take place from outside world to the inside to the microcontroller. So, okay, so we have to learn how to program this port so that data can be transferred from microcontroller to the outside world, and from outside world to within the microcontroller. Okay, so now it's time to have it's time for another question, right? Let's see. Okay, the another question is, think about it and listen it carefully. What is the addressing range of register bank 2 in 8051? Okay, so I hope you remember there are total four register banks which are available in 8051 microcontroller RAM. So what is the range address starts and ends for register bank 2? Okay, so think about it and give me answer in the live session. Then we will announce the prize for that. Okay, now coming to this port programming. So these ports can be accessed directly like P0 or P1 or P2 and so on. So these are directly defined within the compiler as well. Okay, now we also talked about there is a SFR also there. This is SFR is known as the special function register. Okay, so a special function register is a separate 128 byte memory which is available in 8051 microcontroller, and that stores that defines the addresses to these registers, this P0, P1, P2, P3 data pointer, and like PSW and accumulator is also a part of this SFR, right? So several other registers are defined in this SFR, and location is separately dedicated to them. Okay, now if we want to put some value to the outside world from this microcontroller, instead command is simple. We can simply write move p0 comma hash 15h. So if I type like this, that means the 15h will be returned to the p0 pin, right? So let's see how will it look like, because it will be interesting. So if we decode this 15h, right? So this 15h is a 8 bit of data, right? So 0 1 2 3 4 5 6 and 7, right? So let's say it is 5, so it is 0 1 0 1, and then it is 1 0 0 0 1. Okay, so this is the 5. Now we have transferred it to the P0. So port 0 also have 8 pins, right? So this will be the pins of the port 0, right? Pins of port 0. Okay, so what will happen now? We have not covered the hardware architecture of this port 0 and all other ports, so you can go through it. So there is a very special case with the port 0 in 8051. So we have to connect the external pull-up in the case of the port 0, and all other P1 P2 P3 can be used directly, but just for port 0 we have to use these external pull-ups. So we are not going into that discussion right now. We will coming to that discussion once we'll start our tutorials from the hardware interfacing parts. So right now we are discussing it directly. So these are the pins of port 0. So port 0 pins, one will appear at 0, one will appear pin number 2, and at pin number 4 also one will appear. So 1 means, as mentioned in our first class, plus 5 volt will appear at these locations, and 0 0 0 will appear at somewhere, right? So this is how simply we can do simple port in and out operation, right? Similarly, let's say if I type move p1 comma hash aah, okay, in assembly, if the number is starting from some character, we have to put some 0 there. Okay, so this aah means, so if we think about this ah, how it will look like to the port 0 pins. So let's write it. This is the convenient way to write the structure of the register so that you can understand it. So let's say it will be 1 AA, so it is 1010, then 1010. So it will like alternatively plus 5 volt will appear across the pins of this port 1. Okay, so that's it. Now if we have connected any LED or some other device to this pins of the port 1, corresponding to the pins location, plus 5 volt will appear at across that particular device. Okay, again Bhavna Sharma has given the right answer. Okay, so she will also get 20 INR now, because this was a little tough question. Okay, so well transfer, everyone knows the procedure. Okay, now coming to this theory part again. So in starting we are dealing with the theory, and after some lectures we will be interfacing the real components with 8051 microcontroller, and then it will be really interesting after. Okay, so let's say if we have connected some LEDs to it. Okay, so let's say this is the LED, right? So I hope you all of you know the symbol of the LED, right? And the connection diagram. So if we provide plus 5 here, it will glow. If we provide 0 here, it will stop. So if it is because we talked about port 1, right? It is port 1.0. Similarly, up to port 1.7, we have connected the 7 LEDs like this. So what will happen? uh, at pin number 0 it is 0, so it will not glow, right? And +1 +5 volt will appear at that location and it will start glowing, right? So this is how we can write a simple program to turn on the LEDs. So we will be also discussing the process for the simulation of this, and that is for the future part. Now coming to the programming part for today's session. Okay, so let's, yeah, here we have this our KEIL ID. So this was some code which I was working on, and this is written for some other application. So let's go to create a new microvision project. Okay, generally those windows don't appear to you, so let me add window capture. Okay, so it is asking for the location at which we should start it. So let's say we will save it in the same location where we are saving our all other programs, right? Here it is. So online tutorial 0 programs. We will create a new folder here, and then we'll talk about port program. We will uh, type it like port program, the name, and then we'll save it. So now the next window will appear here, right? And this window is like let me check, let me add it to it. Here it is, the different window selection of the driver. So here we will select 8089 S51. So why I'm using this 8089 S51? Because in the upcoming videos we will be teaching live through programming the real 8051 micro. Okay, and we will be programming it with the help of Arduino. Okay, okay, we'll select it and then okay, and then yes. Okay, now okay, now we'll go to the target and we'll create, add new item to the target. Again some new window will open, so let me add that window again to you. Here it is. So we'll select assembly file here, and we'll type it main.asm, and we will add it. Okay, there, that has also been added to it. Now we will type our program. So as main org00h. So that's org00h. Okay, now let's type some simple program. We'll send AA to port 1. Okay, so we'll simply type like move p1 comma hash 0. Okay, first type AAH, I want to show you, and then we will create a infinite loop. We will talk about this sjmp command a little. Sjmp here, and then right, let's save it. So let's compile the program. Okay, okay, so if you see it, it is saying target not created. So let's see, if I make 0 here, now it will not show any error. Yes, and 0 error and 3 warning, and target has been cleared, right? Similarly, we also have not set the options. Okay, we'll set it in upcoming videos. Now we can simulate it. Okay, so we are simply moving AAH to the port 1. So we'll go here, debug window. Okay, and we will add okay, we'll add here port. If you select this peripheral, so this window is not appearing. There will be option input output port, and you can select the port. So let me add this another small window as well. Mm, yeah, yeah, this kind of code will appear here. Now we can run the program. From here we will go one by one. That is the step over. So we'll simply run it, and you will see 1010. So port 1 and 1 pins. That data has been changed to AA. 1010 1010. Okay. So let's stop it. Okay. Stop the debugging session. Okay. Let's say we type now move p2 comma hash 55h, right? So let's again compile it, and let's go into the debugging session. Okay, so again I have to add these sources again. So just give me a minute here. This is one parallel port. Let's add another parallel port as well, port 2. So we have to add as well. So if you are working it at your end, you don't have to do all these things. It will be dark code. So there are total 2 ports which are available, right? Port 1 and port 2. Now let's run command at a time. You will use this one. Step over. Port 1 data has changed, and similarly port 2 data has also. So if you look at them carefully, they are changing the content alternatively, right? So first it was 1010, now it is 0101. So if we can send these data to pins after some time, then it will look like LEDs are flashing. Now in order to send data to a different location for different time, we have to provide some delay in between. So in order to do that, we have to write a program for delay generation, and that we will be going to discuss in our next live session, because for that we have to talk about like machine cycles and all those things. So this is for today's session, and I hope you learned it and you really enjoyed this video, and you enjoyed our new initiative of providing some cash prize during this live session, right? So if any one of you have any doubt, then you can let me know by commenting below this video. Okay, and then I will try to answer those questions, right? And in the meantime, you can share this live session videos to your friends as well, so that more and more people can get benefited for this free live session. In upcoming videos we will be adding more additional contents, like we will be providing uh, more incentives or more cash prizes, and it will be interesting, and we will be demonstrating the programs in real on real board as well as through the simulation. So that is for today. And finally, we also provide online training, help in technical assignments. We also do freelance projects based on data science, Python, machine learning, etc. So if you have any doubt, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So that's it for this video. Thank you.